Welcome again to electrostatic fields. Today we will discuss Coulomb's law. So what we will do today in our learning map, we have point charges. We will discuss about Coulomb law, which basically discuss the electrostatic force. So Coulomb's law statement is that the magnitude of attractive or repulsive force, I mean the electrostatic one here, attractive or repulsive based on the type of the charge. This one between two charges is proportional to the product of the magnitude of these two charges and inversely proportional to the square of the distance between them. So distance is r, then we have inverse square 1 over r square. Then we have the propagation constant k, which is equal to 1 over 4 by epsilon naught, and epsilon naught is simply the permittivity of the vacuum or the free space, and it can be calculated as shown here. Here we discuss Coulomb's law again, but showing the direction. So this the first charge is here, second charge is here, between them some distance or some vector r12. There, this one, we can rewrite the Coulomb law at the magnitude square of this r12, and then we can multiply with the unit vector a12, which is a unit vector in the r direction here, a12. Then we can calculate many methods, but in simple r12 equal to r2 minus r1, and a12 simply the ratio between the vector itself and its magnitude. Finally, here we check for the units. So force is measured by Newton, charge is measured by Coulomb, propagation constant is measured by Newton meter square Coulomb square, and later you will understand it is just meter per farad. Permittivity is inverse of this one, which is just farad per meter, and finally, of course, distance is using meter. Let's have one numerical example. We have two charges, Q1 and Q2. One is positive and one is negative, located at some specific points M1, 2, and 3, and N, which is 2, 0, and 5. This is X, Y, Z coordinates, and they are in the vacuum, means we use permittivity of the free space, and we are asked to determine the electric force between these two charges. So how to solve this one? We just plot it, just imaginary plot. We have two points and we have the charges placed in this point. So first thing to do is to calculate this R12 based on the given point and the unit vector there. So simply you just subtract the n minus m. So here you have 205, 2 minus 1 is 1, 0 minus 2 is minus 2, 5 minus 3 is 2, and we can rewrite this one in ijk, just 1 in terms of I minus 2j plus 2k. Finally, we can calculate the unit, I mean the magnitude. So just root square of every component, 1 square, 2 square, 2 square, and finally you get 3 here. Then you calculate the unit vector by dividing r12 over magnitude of r12, and just simple calculation you can reach this value. And after that we apply Coulomb law, which we have just studied, and simply first calculate the constants. We have the proportion constant, and you substitute using epsilon naught, and simply you get this value, and then you substitute in the full Coulomb law. Just numerical calculation, you will reach at the end that the force is just minus 30. This is the magnitude, and multiplied by a12, which is just the unit vector, or if you like you can also write in this form. And this is all. Our conclusion today is with some analogy with Newton's law. This is Newton's law, and if you note here, you have your r square and you have your r square. You have here gravitation constant. You have here a proportion constant of Coulomb law, and in both cases you have something which attract each other. Here we have m1 and m2 in case of Newton's law. Here we have q1 and q2, but the only difference which we need to note is that in case of Coulomb law, we have two directions with force. One is attractive if the charges are positive and negative, but if they are similar to each other, we have a repulsive force. This is the only difference between the two laws. Thank you.